Hey everyone, today I'm going to be making a physics-based 2D player controller in Unity using the new input system package. In this tutorial, we'll only be adding basic side-to-side movement and jumping. This is just meant to be the basics, but it's designed in a way to hopefully make it a bit more understandable for people new to the new input system and to be expanded upon for those who wish to do that. Now, a lot of people have been wondering, why use the new input system compared to the one that we're already used to? Well, there are a variety of reasons, some being the system being made to be standard in the future. We're not entirely sure how soon in the future yet, but I can imagine pretty soon. It's more intuitive UI for making changes, at least, well, that's a bit subjective, but I believe so. It's more flexible on how inputs are handled, so you can add modifiers to those inputs, which helps with controller control flexibility. And then it's got very easy controller support and can be hooked into a lot easier than the original system for things like rebinding controls. Okay, now that we've got that all out of the way, I think we should just hop straight into it. So let's get started. Okay, so here we have a completely empty basic 2D scene. We created this obviously by opening up Unity Hub, which you should have downloaded, and creating a new project that was of the 2D base type. Firstly, you need to import the new input system asset if you haven't already. To do that, you go to Windows, Package Manager, then you change from in project. Once it's finished loading, go from in project to Unity registry. Then there you click input system, and then you should have the button here to install. Once that's been installed, you'll get this pop-up saying that the project is using the new input system package, but the native platform backend is using the original. You just want to simply hit yes, and what that will do is it will make all the changes it needs to make, and then restart your project. Once that's done, you will see that the package manager is still open, but everything has been restarted just as you left. What I'm going to do is just expand this area real quick. And so first thing we will do here is make a level. Pretty simple. I'm just going to build a very basic one. We're going to call this ground. I'm going to scale this to be about 50 by 20. That at minus 15. See. Okay, so what? Okay, minus 10 minus 12.5. Minus 12.5 would do for this. So once you've got that in the ground, you can I'm going to change the color real quick to basic gray. And I'm going to go ahead and change the background color to something like a bit more of a, I'm thinking an orange. Yep. So now I've got the ground and main camera's color, background color has been changed. After that, you're gonna make another 2D object. I'm gonna make it again a square, but you can make this circle, although for the tutorial we are going to go with a square. just due to the fact that box collision is a lot easier to understand. And we're going to name this player. We're also going to tag this as player. So now we've got our player and we've got the ground. So what we're going to do is we're going to now add a rigid body to this player object, which will require rigid body 2D component. We're also going to need a box collider 2D to actually be able to collisions. You're going to need this on the ground as well, so don't forget to enable that. Then on the rigid body, for now we're going to leave everything the same. Everything is going to remain exactly by default. Lapse some of these options here, and just to clean up the view. Okay, so before creating the player controller script, what we're going to do is go right click in the project window, go create, and then input actions. This is the asset that is used to read inputs in the new input system. We're going to call this player actions. And what you want to do is tick this generate C# class asset and just hit apply to confirm that. We're doing this in order to access the input readings and the input layer that we have set up, that we're about to set up, but we can read it through C# code rather than having to use any extra components, although that is something you can do, but we're not going to cover it in this video. So I'm going to quickly tick autosave here. To open this window, by the way, I clicked edit asset, and this opens up. I'm going to dock it here, and now we're going to simply set up our inputs. So we're going to have an action map, which will be called in-game. And with that, we're going to take this new action, rename it by pressing right click and rename, and we're going to name this the move. Now we're going to delete this binding. Delete. Okay, so I had to take a brief pause. So basically, we rename this action to move from new action, and then we want to add a 1D axis composite. I'm going to call this, when it responds, we're going to call this keyboard. And then we're going to bind these negative and positives to A for the negative, because that will be left, and D to positive. So we now have movement binding on a 1D composite here. We want to set this to a value. Control type reads axis. Turn this into an axis. Then after we've done that, we want to add another action, and we'll call this jump. Then we're going to bind jump to spacebar. Now, before we continue, we're going to add a control scheme. We're going to call this keyboard. We're going to add keyboard as a required device. We're going to hit save. Then we want to set these axes here as keyboard. as well as the spacebar, because these should be specifically within the keyboard control scheme. Okay, now we have that. We want to create our player controller script. So what I'm going to do is I'm going to click the player, go add component, and type in player controller. Create and add. And then once that's created, we're just going to double click. Open in Visual Studio. It should be installed on your system. So, first of all, we're going to need to implement our input actions. I'm going to delete everything in this class firstly. Then we're going to do a public player actions, and we're going to just call this actions. Then with this, you want to then do an awake void and do actions, new player actions. This creates a local instance of the player actions C# script that was generated when we tick that. And just to make sure, we go here and ensure that this autosave is on, that this was ticked as it was. If it wasn't, then this would not pop up properly. And then from that, what we're going to do is set up some basic things. Oh, before that, we want to do on enable. Here we want to do actions dot enable, and in on disable we want to do actions dot disable. If we don't do this, the script will not start picking up the inputs. So we have to do this, at least do enable. Disable is specific for if the asset gets turned off, say, by player death, for instance. We don't want them to be able to continue moving around while they're technically dead. So that's why that sort of thing is done. So, now we've got that, we're just going to add a few more variables up the top here. So first off, we need a reference to our rigid body 2D. We're just going to call this RB. And then we're going to want a few things, such as public float move speed. I'm going to default this 10. And I'm also going to do jump force, which I'll default to about 5. So now that we've got that, we're going to want a few booleans as well. This is for later, but they are important. So we're going to want boolean for can jump. We're going to default this to true. And then we're going to have 2 other booleans here that are basically reading a state. So we've got bool jumping and rounded. With these commas, when you do commas like this, it is effectively the same as doing public float jump force like that. You can just put a comma there instead, if you weren't aware. So, now we've got all those in, we're going to need one final float, I'm pretty sure. Checking, yup, we do indeed. And this is again for later, but it's good to have in. Float max slope angle. I'm gonna set this to 35. Okay. So now we have basically almost everything in that we'd need in this regard, but for now, this will do. So firstly, let's make our movement function. So we're going to make this just standard void. I'm going to call this player, and it's going to take an input of type float, and we're just going to call this input. So what we need in here is an internal vector 2 called final vector. We're going to call this. We're going to obviously instantiate it as a new vector 2, and then what we're going to do is in here we're going to check if can jump is true, so we can just do is can jump if can jump, as well as if jumping, we will then call a later jump function. We will quickly define that now, just so we get the red line away, because after all, that's we're really aiming to do whenever we program. That is to do. Boom. Okay, so now we want to go back here, and what we're going to do is do final vector plus equals new vector 2. Going to take input dot not dot times move speed times time dot delta time. Then for the y value, we're just going to do rb dot velocity dot y. Then what we're going to do is then set rigid body's velocity is equal to final vector. So if we save this, but here's the thing, if we save this, this is a little trick here. You will probably have noticed by now, but if not, when we hit play and we hit left and right, nothing's going to happen. And that's because we haven't told it how to interpret our inputs. So what you need to do is, I'm going to do this under awake. You want to make a fixed update. Since this is all physics-based movement, you'd want to do that in fixed update. You don't want it to be frame rate dependent. You're then in fixed update going to call move player, and then for the float you're going to do actions dot in-game dot move dot read value of type float. And now, if we go back in, should, in theory, when we hit play, we should then be able to hit left and right. Fortunately, it doesn't seem to be working. Oh, that's because rigid body was not applied. As you can notice, it is moving, but 10 is quite little. So we're going to up it to 100. That's a lot better. For this 500, that's quite fast. I'm probably going to set it to about 300. And I think that is perfect. So now that we've got that, let's implement our jump function. So firstly, we're going to ensure that they're actually allowed to jump. So first off, we're going to do if grounded we're going to set can jump is false. I think I also can jump in here. Wrong. But let's do that to be safe. And then, so we're setting can jump to false. As soon as we do jump, we're then going to rigid body dot add force, and we're going to do vector2 dot up times jump force, and we're going to define the force mode 2D, which is basically how it's applying the force. So is it linear, or is it like just a sudden impulse? So that's why we're doing force mode 2 dot impulse, because we want it to be a sudden burst of force rather than a smooth transition of force. So we're going to do that. And then after this, we're going to invoke the new function that we're about to create called reset jump. We're going to do that after 0.1 seconds. So now let's quickly make reset jump, which is really simply reset jump this is a very simple function. It's all it's going to do is set can jump true. That is all it will do. Now, this will not jump for a few reasons, actually. So I'm pressing spacebar, but nothing's going to happen. Set the rigid inspector, just to remember to do that. A few reasons, because one is due to the fact that we're never actually setting jumping to true, so it will never actually trigger jump. To do that, what we're going to do is back in awake, we're going to set actions dot in-game dot jump dot performed plus equals, or since we don't actually need to read context, this is a delegate. This is a delegated process. I would get into how exactly they work, but there are plenty more videos on YouTube that will describe this far better than I will. So after that, you want to type jumping equals true, and we're just going to duplicate this line, Control D, and we're going to replace performed on this one with cancelled, and change that to false. So now it will go here. Now do this, but there is going to be still an issue. If we wait for it to load, press play, and see that even though I'm pressing spacebar, nothing is happening. And that is because if we go to the debug mode, here we will see that grounded is never being checked. You can just manually check this by just setting it to true by default code, but we don't want to do that. What we want to do is have properly discrete and automatic ground collision detection. So what we're going to do is we're going to go back to Visual Studio, and we're going to create a few more functions. We are going to need a boolean is floor with an input of vector2 called normal. For this, we're going to take a float called angle, and we're going to equal it to vector2 dot angle being vector2 dot up and the inputted normal, and we're going to return the true or false of if the angle is less than max slope angle. So if the surface we're touching, put it simply, if the surface we're touching has a higher slope or angle than 35 degrees, it will not be considered the floor. Thing at 35 degrees, or no, anything lower 35 degrees, be considered floor. So we want to then take this, and we're going to want another local boolean cancel grounded, and from there we're going to make a new private void on collision stay 2D. So firstly, we're going to go int layer collision dot game object dot layer. Now here is something we will quickly need to add up back at the top with our variables. We're going to, under here, we're going to serialize the field so we can see it in Inspector without making it public to any other script. We're going to want to do a layer mask, and we're going to call this ground layer. So now we have that, we're going to say if ground layer not equal to ground layer basically all this is doing is making sure the ground layer is matching the collision layer. That's all that's doing. And if it doesn't match the ground layer, then we're going to return, because we don't want it to do anything, because that's not the ground. So after that, we're going to make a for loop in I equals 0, I less than collision dot contact count I plus plus. So now what we're going to do is go for vector2 equals the current contact that we're reading through. We're going to compare the normal to it. So we're going to store the normal there. And then we're going to feed in that is floor boolean, again, comparing it to that normal. And if that is considered to be the floor, we're going to set grounded to true, cancel grounded to false, and we're going to cancel the invoke of a of a separate function called stop grounded. Then after that float, we're going to do another local that for loop. Sorry, we're going to do a local float called delay. We're going to set this delay to 3, and we're going to say if not cancel grounded. Going to say cancel grounded equals true, and then we're going to invoke name of a function by the name of stop grounded again, but this time we're going to delay it by time dot delta time times by the delay just defined. So now what does this stop grounded do? Well, it's just like reset jump. It's a really simple small function that very simply just sets grounded to false. And now, as far as I understand it, this should, in its entirety, work. So, now we can move around. The move speed is a little weak, so I'm going to crank it back up to 300. Now if we press spacebar, it's still not jumping. Oh, of course it won't. That's because we need to go into ground. We're going to make a new layer. We're going to put it in element 3. That's just due to how I like to put it in. I'm going to call that ground. I'm going to put the layer, be ground, on the ground object. And then in here, we're going to set ground layer to the ground. So now we're going to hit play. And now we can jump. But the problem I personally find with the jump in this state is that it's rather floaty. This might be something you want in your game, but I feel it's just not snappy. So how I'm going to remedy this is with a small addition. I'm going to serialize this field. And I'm going to... Actually, no. I'm going to make this a public float. Added gravity. Actually, go add it on top of here. And we're going to call this 5 for now. So now that we've got the added gravity float, what we're going to do is inside of movement, inside of the move player function, right before we check if we can jump, we're going to add a check. And we're going to say if rigid body dot velocity dot y is less than 0. No, more, sorry. Right. Less than 0. So you're falling. If that is the case, we're going to then say final vector plus equals vector2 dot down times time dot fixed delta time times added gravity. And now, with this change, we can wait for it to compile, and finally we just hit play. Okay, sorry about that. There was a technical issue that caused the recording to crash. But thankfully, this was the last piece. So now we press play, and we will see that when we jump, we are falling faster than we're going up. And this is a lot more evident if we increase our jump force. Let's just increase this to 10. And we'll increase the added gravity a little bit as well to 6. So now we jump up high. We fall a lot faster. Go up. If we just set both of them to 10, it becomes very apparent. But yeah. So that is basically the entire movement controller set up. And now as a final piece, I'm going to demonstrate how to implement controller support. So what I'm going to do is I'm going to quickly grab my controller wherever I put it. It is, it's behind here. So I'm going to take my controller and I'm going to plug it into my PC. So now the controller is plugged in, and what we're going to do is we're going to go back to player actions and we're going to add a new control scheme, and we're going to call this controller. We're going to make the control scheme require a gamepad, and we'll just hit save. And now for this, we're going to add another 1D composite axis binding into move. Once that's loaded, we can the axis and we're going to bind the negative to left stick left, and we're going to bind the positive to left stick right. So now that we've got those bound, we can also quickly add a binding to jump, which will simply be the south button, which is the A on an Xbox controller or X on a PlayStation controller. We'll bind that to the southwards button on the gamepad's face. And now, if we go back into the game and hit play, you will see that now I'm using the controller, and it is now completely functional. And with controller, you can have a lot finer control with your movement, where you can slightly tilt the stick and whatnot. So there you go. That is basically everything. That is how you set up your own 2D platformer controller, how you set up the input actions binding, and how you read those inputs, as well as setting it up to use multiple control layouts such as keyboard and controller. I really hope that this video helped you guys with setting up your player. If you need any help, please just leave questions in the comments down below, and I will get to them as and when I see them. Okay, thank you for watching, and good luck with developing your game.